Okay, good morning. So let us continue the lesson. Today is a very long lesson, so I will just give you some more examples, and this would be our last session about on the topic of systems of equations. I want to give you some more examples and then give you some extra time to practice on your own. So if you remember the last system of equation that I wrote on the board, but we didn't have time to finalize it, was this one. And this came after the idea I introduced to you as the auxiliary variable. Sometimes introducing some set of new variables to the problem makes the problem easier to solve. Of course, if you want to understand when to use this idea, you have to practice a little bit so that you can train your eyes, so that you can catch the patterns immediately. So, for example, I think you see that this problem, something is repeating itself in the first equation and in the second equation. This might motivate you to introduce some new sets of variables in, yes? So, for example, without a further explanation, can you tell me what is your opinion if you want to introduce a set of new variables? Yes, Oscar?
I set 1 over x plus y minus 1 as capital X.
So let me just, so you say that, let me follow yours. So you put capital X to be what?
1 over x plus y minus 1.
Yes? And then y?
It's 1 over 2x minus y plus 3.
Plus 3. Yes, that's a good choice, I think. So we introduce these two new variables. These are all auxiliary variables, and then we plug them back into my equation. But of course, you shouldn't lose the logic. The logic is to find, at the end, I am supposed to find little x and little y. Yes? But introducing these variables makes the form of my system simpler, so that I can solve that problem and find capital X and capital Y. And then using those values that I will get, I will probably, hopefully, be able to find x and y easier. Okay, so let us just do this to see how it goes. I plug these two into equation. This one can be written as what? Because you have introduced that this expression is 1 over x plus y minus 1 is x. This is nothing except 4 times capital X. Is that understandable for everyone? So this expression is 4 capital X minus, this is 5 times this expression. So it is 5 times capital Y, and then I have plus 5 over 2 equals to 0. And I hope that you agree with me, at least the form of this equation is simpler than the form of the previous equation, yes? And then I do the same thing here, so it becomes 4x, and then I have plus y, and then I have 7 over 5 equals to 0. So I am more or less facing a very standard system of equations in two unknowns, and I will try to solve that one. And I think method of addition is better. Yes?
Wait, Baba.
Yes?
Yesterday it was 4 over x plus y plus 1 on one of them. And the other one was x plus y minus 1.
Let me see. I don't remember exactly what I have written. So you mean this is not the one that I wrote yesterday?
Only it's one of the 4 over x plus y is instead of minus 1 is plus 1.
This one?
Wait.
No, even if I have written that, so I mean that if they are different, that is wrong. Might be that is... The one that I have written here is now correct. I can double check. That is correct. Okay. And then I need to use one of the methods to solve that one. I think method of addition is better here if I want to use it. But of course it is easy to see that I can get rid of this x. So the price that I have to pay is, for example, to multiply the first one by a negative 1. Of course you can also multiply by 2 to get rid of the fractions, but I see that I can get rid of x, so let us do that one first. So you shouldn't think about mathematics as a rigid subject. You can be creative in the middle. You really don't need to follow exact rules. You can just change them according to the problem in hand. So I multiplied by a negative sign. It becomes minus 4x. This becomes 5y. And minus 5 over 2 equals to 0. And then I have this one, 4x, or sorry, capital X plus y plus 7. And if writing capital X and little x are different, it's hard for you, you can choose different letters, of course. Equals to 0. And now I add them side by side. This one and that one will be cancelled. Y plus 5y is 6y. And then this one is 7 over 5 minus, I can do it in a scratch paper, for example. Here I have 7 over 5 and I have minus 5 over 2. The common denominator is 10. 2 times 14, 5 times 25, yes? So it is minus 11 over 10. So, and then I move 11 over 10 to the other side. 6y is 11 over 10. Then I want to make x alone. Can you do it in your head? What is the answer for capital Y?
It's lower over 60.
60. Because when I divide a fraction by a number, it means that I multiply the denominator by that number. So is Oscar, is the number that you got, is this one? Yes. Yes, okay. So this is y, but don't forget, the problem for y is not still finished because I want to find a little one. Keep silence, please. Thank you. Okay, now I go back to one of these equations. I plug that y in. I think it would be preferable if I use this. Yes, do you agree with me? Because the coefficient is small. So I put it here. So then it becomes 4x. Then instead of y, I put 11 over 60. And then I have 7 over 5 equals to 0. Of course, you can multiply by 60 if you want to get rid of all fractions. Is that a good idea? Yeah, let us multiply by 60. I want to get rid of the fractions. Of course, you can add the fractions, move it to the other side, and divide by 4. That also works. But if I multiply by 60, this becomes 240x. When I multiply it by 60, it becomes 11. And when I multiply it by 60, can you do it in your head? If I multiply 60 here, the 60 that I am multiplying and the 5 in the denominator,
It's 42.
it becomes how much? 12. Yes?
Yes.
And then I have to multiply 12 by 7, which is 84.
Oh,
Yes? So it is 84. Equals to 0. Yes? And then I add those numbers, move it to the other side. It is 95. I move it to the other side. It's minus 95, and I divide by 240 to get x. So it's minus 95 over 240. But you shouldn't leave it like this. I try to simplify it by 5, because it is divisible by 5. Divisible by 5, definitely. If I divide this by 5, it becomes 48. Yes? And if I divide this by 5, how many times?
19.
19. And I have a negative sign. And this cannot be simplified. So, yeah, the numbers are not that good, but anyway, it's manageable. Sometimes, of course, you might need your calculator, but so far we were able to manage that. Is this the number that you got? Okay, good. And then, well, let us plug things where? Here and here. Because now I want to find little x and little y. Yes? So what should I do? I start from here. You tell me that x is minus 19 over 48. But what is x? X is this expression. It is 1 over x plus y minus 1 is equal to minus 19 over 48. And I told you that it's always good to remember, if two fractions are equal, the product of extremes is equal to the product of means. So I always use that if I have two fractions. So then what does it mean? It means minus 19 multiplied here it becomes minus 19 times x plus y minus 1 equals to 48 times 1, which I have written it like that. And then I multiply minus 19 in, is equal to 48, and finally I move 19 to the other side. So it becomes minus 19x minus 19y, and then 29, yes? 48 minus 19 is 29, yes. So this is the equation that I get. And I have to do the same thing for y. Y is this expression, but I got y equals to this, so I equate them. It becomes 1 over 2x minus y plus 3 is equal to 11 over 60. And again, I use the same thing. The product of extremes is equal to the product of means. So it means that 11 times 2x minus y plus 3 is equal to 60. And then I multiply it. It becomes 22x minus 11y. And I multiply it here. It becomes 33 is equal to 60. And then I move it to the other side. 60 minus 20 minus 33 is how much? 27. Okay, so the numbers are not so good now. We have to deal with it, okay? So I have now at least two standard systems. So I have to put them in a system of equations and solve them. Okay? Okay, so I have to set up my new system, and if I succeed to solve this new system, then I am done. So what is the first number is 19 minus 19, x minus 19, y equals to 29. And the other one is 22x minus 11y equals to 27. I hope that I haven't done mistakes, but let us see how it goes. Okay, we have to solve now this problem. I don't know, do you have any suggestions? Because either you have to use substitution method or addition method. So which one do you prefer? It doesn't matter, let us use addition method. But if you want to use addition method, let us focus here. For example, I multiply the first equation by minus 11. And then I multiply this equation by 19. Yes? So what do I do? Let me just multiply the first one by 11. I have to multiply minus 11 here. So what is the answer? So 19, 19. So it is 9, and then I have 10, 2. So it is 209 x. Here, I don't need to bother to multiply, of course, but it becomes also positive 209 y equals to, I multiply this one here, 29, 29, so it is 913, 319, yes? And then I multiply this by that, so this is 200, what was that, 209, and I multiplied by this 418, yes, x, and then this becomes minus 209y, then I have to multiply this by that, so it is this time, but I need to subtract 27 from it, so it is 513, yes? But you can use a calculator, of course, and please double check my calculation. Yes, please.
Isn't it negative 419?
What then?
Isn't 419 supposed to be negative?
Yes.
Here,
Because it's minus 11. No.
here,
Yes.
I multiply this in, yes, this one you mean. Yes, thank you very much. Thank you. Okay, now I add them. When I add them, this is cancelled. I have to add these two numbers, 9 and this is 7, 2, and 6. Yes? X is equal to, if I subtract them, it is how much? 4, 9, 1. So am I right?
Yes.
Did you check it?
This is what I put.
Okay.
Yes.
And then x is equal to 194 divided by 627. Can I simplify it more than that? I don't know actually.
It's divisible by 3.
No, this is not divisible by 3.
It is not?
No, because the sum is 14. Yes? If the sum is not divisible by 3, it is not divisible by 3. Okay? So I'm lazy to go through the calculations, but if you want to see that if it is simple, you can simplify it or not, you have to factorize it somehow, which is a hard thing to do. Yes. And if you don't simplify, please do not talk that much. Okay, you are distracting me. Hello. Okay. So, if you want to see that this can be simplified more than that or not, what I'm supposed to do, there is no way unless that I factorize it or I know the numbers. But yeah, I am a little bit lazy to do that, but let us anyway do it. If I factorize this, so I divide by 2, what's the answer?
97.
97, yes. And then is 97 divisible by a famous number or is it prime? How do you know that 97 is prime or not? I think 97 is prime. Isn't it? Because how do I understand it? I take square root of 97 in my head. It's smaller than 10. And then I take the prime numbers 2, 3, 5, 7, that's it. If this number is not divisible by that, then it is guaranteed to be prime. And it is not divisible by any one of them. So that's a prime number. So it means that if I want to simplify that, it is just 2 times 97. But can I simplify this more than that? So let me just factorize it. This is definitely divisible by 3. It is 209. But what about 209?
19.
Pardon?
19.
Ah, yes, you have it here. Thank you. So you divide it by 19. It becomes 11, yes?
Yes.
And then you divide by 11. And then you see that there is no common factors. So really this cannot be simplified. That's the end of the problem. Yes? This is your very nasty x that you were looking for. Nice. Yeah. I don't know why they have chosen these numbers, but anyway. So, but of course, it is not guaranteed. I really want to put this in Geogebra to see that if we have done all the calculations right. Okay? But the problem is not finished, unfortunately, because I have to plug this bad number into one of these equations and try to find the other one, and that would be the disaster, yes? So what I have to do, I put it here, so I would multiply this by minus 19, but I regret to clean this. Do you remember what was this? So I multiply this by this number, and then I have minus 19y equals to 29. So do you remember I factorized that? What was that? 3, 19 and 11. Do you remember?
Yes.
And then this 19 and that 19 are gone now. So what is left for me is minus 194, 33. Minus 90y is equal to 29. Okay, and then what I do, I write 19y, I move it to the other side, and 29 to the other side. 29. Yes?
Wait,
And then,
Baba,
yes?
you didn't really move 29, did you? It's
No, I
still on the
actually
right
move this in my head to the other side, and then this one to the other side, and then write it the other way around. But of course, if you want, I can move it. Okay, it's easier for you. Let me just do it the other way. So I keep minus 19, 9y here. I just move it to the other side, yes? Might be that was a stupid way of doing things that I did before. Thank you. Okay, so that's this. And then what I have to do, I have to bother to take the common denominator, which is 33. Do you mind if you multiply it here? So 2, 9, 2, 9 is 9, 11, and then I have 3, and then I multiply it by 3, so it becomes 942. And then I have 194 here. May you please check it with your calculator. And then what happens here is 6, 13, 11, 33. May you please check it? Because I also to check it with Geogebra later. So multiply 29 by 33, is that number right?
No.
No?
It's 957.
900? Thank you. 957. Okay, and then please add these two numbers. 57. And then add these two numbers.
1151.
Yes. Okay, and then finally you need to do one more favor to me. I divide by minus 19. So this is very, very strange. Hopefully I haven't done any mistakes. Multiply 33 by 19 once more.
It's minus 60, 11 over 19.
What?
Minus 60, 11 over 19.
No. Just multiply 33 by 19.
627, right?
27. I don't know. These are the numbers that we get. So I think it's a little bit. I'm a little bit suspicious, but let me see that if I have written everything correct, because I want to put it in Geogebra. See that if Geogebra is first of all capable of doing this. 5 over 2x minus y plus 3 plus 5 over 2, 0. 4 over x, yes. So apparently I haven't done any mistakes in writing it down. So I will pause recording, and I don't know, the people at home, I don't know how can I share it. I will try to find a way, okay? Okay, so let me just try to use Geogebra to see how it goes. So I will write solve, and then I need to find a list of equations, solve list of equations, and then I have to type that equation. It takes a little bit of time, but I think it's worth it to see if we succeed to write it. And if you remember, for solving a system, you have to put the curly brackets, and I have 4 divided by x plus y minus 1, and then I have minus 5 divided by what? 2x minus y. Please check my typing. If I make any mistakes, let me know immediately. Plus 5 over 2 equals to 0. This is my first equation. I have to separate it by a comma. And then I have 4 divided by x plus y minus 1. Then I will go here plus 3. No, plus 1 divided by 2x minus y plus 3, and then I have plus 7 over 5 equals to 0. No, 5 divided 7 over 5, yes. 7 over 5 equals to 0, and then I go out, I write my variables. Yes, so let me see how it works. I don't know why this disappears.
Control Z.
Control Z doesn't work.
Oh no,
It's calculated. Oh, it's back. So it was actually, was it right?
it was right.
Yes. Correct.
So yes, we actually did it correctly. Surprisingly, we didn't have any mistakes. So yeah, at least this is confirmed that what we have done is correct. That's exactly what we got, yes?
Yes.
Let me go behind the curtain to see. Minus 11, 51, 621, 7 is y, yes, and then what was the other one? Yes, exactly. So, yeah. Now we succeeded to solve it completely right. But, I mean, now assume that if you haven't introduced the auxiliary variables, then you have to do a lot of calculations, algebraic calculations. So now we can say that we succeeded to solve this problem. Good. Okay, we go back to the lesson. So let me pause this recording. So I don't know where the pause button is gone. Okay. Okay, so I think they could have adjusted the numbers a little bit better, but anyway, we succeeded to solve the problem. Okay. Now, this idea was clear. Let me give you an example of I want to practice a little bit here as well. So, let me just remind you about a system of 3 equations in 3 unknowns. Okay, we have now, I think you have quite good experience in solving systems of 2 equations in 2 unknowns. Yes. Now let us improve it by just solving one more problem for the system of 3 equations in 3 unknowns. And then I have this one. Okay, I haven't solved so many problems related to this, but can you tell me, for example, what I'm supposed to do here? I want to solve a system. I think it would be a good idea if I give you time, because if you can solve it on your own, it means that your understanding is perfect. So I give you 5 minutes for yourself to do this, and then I will come back and solve the problem. The people at home, if you still are interested in working on the problem, please take a note. I will give you 20 seconds, then I will pause recording, then you will not be able to see the board anymore. Okay, everyone, please work on it. 5 minutes from now. Okay, did you get the answer to this?
Yes.
So what is the answer?
X is
Yes?
48 is X, 27 is Z,
Yes?
and the Y is minus 47. 74.
Do you agree?
Well, I got X is 6.
The small numbers, okay.
No, yeah, wait, X is 6, Z is also 6, and Y is minus 11.
Okay. What about others?
X is negative 72, Y negative 53, Z 20.
That was not your answer, was it?
No.
So we have 3 opinions, 3 different answers.
I mean,
Anyone at home?
I also got I think a 4th possibility.
4 possibilities.
Yeah, that's X is equal to 5, Y is equal to negative 11 over 4, and Z is equal to 13 over 4.
So what are the other possibilities? That is only one possibility.
Oh yeah. Wait, I meant that I got a separate answer.
Okay. The 4th possibility. Okay.
Yeah.
All right. Let us see. Let us see which one is working. So this shows that your calculation is not precise, or at least you're not paying attention. So which one you choose? You need to choose one of the equations and eliminate one of the variables, yes? Which one is easier to choose here?
first one.
First one. And which variable you prefer to get rid of? If you say so, I will get rid of X, but I prefer to get rid of Z if possible, but that's just tradition, yes. So I eliminate X. So what I have to do, I have to write X is equal, move the other ones to the other side, 1 minus Y minus Z. And then I have to take it and put it here, and take it and put it here. Then I will get a system of 2 equations in 2 unknowns Y and Z. And then I already know how to solve that. But I have to do a little bit of algebra. If instead of X I put 1 minus Y minus Z, then I will have plus 2Y plus 4Z equals to 8. And I simplify that a little bit. So 2Y minus Y is just Y. Minus Z plus 4Z is 3Z and then I have 8, I move 1 to the other side, it becomes 7. So that is one equation. You don't have to eliminate x, but your final answers have to match. Okay? And then if I put x, then I would hear 1 minus y minus z, and please try to to follow my calculations. If I have making mistakes, let me know. Okay, then what happens? This one and that one becomes 2y, and that one is minus z and z 8z, and then I move 1 to the other side, so it becomes 26. I do not stop here because I see that I can divide everything by 2. I make it simpler for myself, so it becomes y plus 4z equals to 13. And then I set up a system, which is a very simple system. Y plus 4z is equal to 13. Y plus 3z is equal to 7. And here I prefer the method of addition by multiplying this by a negative 1 and adding it up, yes, with the first one. So let us just do it in our head. I multiply minus sign here, it becomes minus y. When I add it here, they are gone. I multiply minus 1 here, it's minus 3z. When I add it here, it becomes just z. And then if I multiply here, it becomes minus 7. Added here, it becomes 6. I don't know who got z equals to 6. Oscar, and what about you, Rasmus? I don't remember your answer.
I had the wrong one.
Yes. I barely hear you. Okay. So
It was wrong.
oh, it was wrong. Okay. So z is 6 here. Of course, we can check because it might be I am doing some mistakes, but we can check it at the end because this system is not hard to check the answers. Okay, z is 6. What I do, I plug it back into one of these equations. Which one is simpler? Let us put it here. I will have y. I have z6 multiplied by 3. It becomes 18, and it is 7. And when I move it to the other side, y becomes negative 11. Was it right? Yes. And then I prefer to use this for finding my x. So I take these values and put them here. So what happens here? It becomes 1 minus 11 and minus 6. So it is 1 plus 12 minus 6, which is 7. Yes? So x is?
No, wait, it's 11, it's not 12.
Ah, okay, 11. Thank you. So it becomes how much?
It's
5, 6. Yes?
yes.
Thank you. But if you want, we can check it. Is the sum of these three numbers we got equals to 1?
Yes.
So 6 minus, yes, yeah, it is minus 5, that's correct. Let us put it here. X is how much is 6? 2 times y is minus 22. 4 times z is 24. Is it equal to 8?
Yes.
Yes, because this is 2 and this is 8. So that's also correct. Let us put it here. 6 minus 3 times y, which is positive 33. No, negative 33. Yes, and then I have 9z. What? It is 54. Is it really equal to 27?
Yes.
So how much is, yes, it is 27. Yes. So it means that the answers that you got is completely correct. But I don't know, you need to see where you have done some mistakes. If it's just miscalculations, it is important, but not that important if you have some concepts going wrong.
And this is a unique solution.
And that's a unique solution. Any questions here? Okay, let me write one more. This a little bit, I have seen similar things in the book. So let me write another system for you. I think if I give you simple systems like that, I think you at least know what to do. It might happen that you have done some miscalculations. It doesn't mean that you don't understand what to do. But let me make it a little bit harder. I have seen some examples, some similar to what I want to mention in the book. And I want to give you time to think about it. So the system is this. I want to write it in this format, a little bit unusual way. X minus 2 over 5 equals to y plus 1 divided by 3 equals to z minus 3 divided by 2. And then I have another equation here. So, the people at home, please try to take notes if you want to work on the problem. Before starting the problem, I want to ask you some questions and then you can start. First of all, if I ask you how many unknowns you see in this problem, it is trivial, x, y, and z. But how many equations do you think that I have in this system? Three or four?
I would.
It is 3, yes? How many? What do you count? You count the number of equalities. The reason that it is a little bit suspicious might say that there are 4 possibilities here. This is one equation, definitely. But how many equations are here? 2. You might say that no, there are 3 because I can consider these 2 one equation. I can consider these 2 the second one. And I consider these 2, this is the third one. Is this the correct way of counting the number of equations or not?
No.
Because that is not wrong, by the way. When I say this is equal to this is equal to that, so this means that this equality is one equation, this equality is another equation, but definitely these 2 are also equal, so this is another equation. Is this way of counting correct? At least it seems reasonable a little bit, yes? It is not completely out of subject. But which way do you count it? If you count these 3 equations and this one equation, how many equations you will get? 4. And then how many unknowns you will have? 3. Yes? So it means that you have 1 degree of freedom left. And if you have 1 degree of freedom left, how many answers you expect? If you have 1 degree of freedom, it means that 1 variable is free. If 1 variable is free, you can assign any number that you like to that 1 free variable. So this means that you should expect infinitely many solutions. So that is crucial to understand how to count the equations. Okay, how do you answer this question? The way that you answered it first was correct. There are really 3 equations. But why the way that I am counting is wrong if it is? Okay, so let me answer. This is a deep question actually somehow about the degrees of freedom. So I didn't count it wrong. When I say I can write 4 equations, I am totally right. Yes? This is 1 equation, and I can write 3 more for you. 1 equating these 2, 1 equating these 2, and 1 equating the first and the last. But the point is that even though I can give you 4 equations, but these 3 equations are not independent. It doesn't provide me extra information. Yes? For example, if I say A equals to B equals to C, I can write 3 equations here, 3 equalities, yes? All of them right. But these 3 pieces of information are not independent pieces of information. Why? Because if I accept this one and this one, this is automatically satisfied. So that's not an extra piece of information. Do you understand? So this, I cannot say that I have 3 pieces of information on the board. I have written 3 equalities. I have 3 equations. But how many pieces of information? How many independent pieces of information these are giving to me? Only 2. Because when I accept these 2, the third one automatically is satisfied. That is not under my control. So, how many degrees of freedom? So I have 2 constraints, not 3 constraints. 1 constraint, second constraint, the third constraint is an implication of the first two. So if I ask you how many equations I can write here, of course I can write 3 equations. But how many independent equations I can write here? Only 2. And then 1 equation here, it becomes 3 independent equations. How many variables I have? 3. And these 2 match. Whenever these numbers match, you should expect a unique answer, but not always. I'm just giving you a feeling how to think about the problem. Okay, so at least you understand what is going on, and I want to give you 5 or 6 minutes. If you need time, I can increase it. But think about the problem. The people at home, please take notes, and then I will pause recording the video in 15 seconds. Pausing the video now. Okay, any answers yet?
Okay,
Okay, I can wait a little bit more if you need more time.
I think I might have made a mistake though, so.
Okay, but that is just very natural. You have to repeat the calculation sometimes.
Yes.
Okay, no answers yet?
I don't, I mean, maybe not, but I mean, this doesn't look right, but maybe.
So
I just have one.
So what is your answer, Rasmus? X is equal?
I haven't got an answer. I just have said.
Okay, so what is Z?
521 over 23, which does not feel correct.
Yeah, let us not rely on the feeling. I had the same feeling when I was solving the first equation. I was always thinking that I am making something wrong. Yeah, we cannot rely on feelings. Of course, the feeling is good, intuition, but let us see. Okay, let me, yes.
I got y is equals to 705 over 23.
705
Yeah,
over
23.
22.
23.
23. But I don't know for the so Ross. Okay, that is also 23. At least you have something in common. Might be it is not completely. Yeah, might be we should be expecting something like that. But let me calculate things. I don't know what is your strategy in tackling the problem. How did you do that then? So what is your starting point? Yes?
Okay, so I began by multiplying the first one with 30.
Okay, so you are using the product of extremes equals to the product of means for these two?
Yeah.
Or no, everything by 3?
I just divided everything by 30. I multiplied everything by 30.
By 30 to get rid of all the fractions, yes? Okay. Because the way that I want to do it is different.
Yeah.
But I just want to tell you that if you understand what is going on, in principle, you should be able to solve it without knowing what I'm going to tell. Yes? So, I don't know if you should go for you or not. So, let us follow yours, okay? So, let me just do that very quickly. I multiply everything by 30, you said, yes?
Yes.
When I multiply by 30, this is 6 times I multiplied there. So, this becomes 6x minus 12. This becomes 10y plus 10, and this becomes 15z minus 45. Yes? Is that what you mean?
Yes.
And I multiply by 30.
Yes.
And then, of course, you are right. Then what you need to do, you need to consider 2 of them, and then try to eliminate one of the variables. Okay? I don't want to disturb you with that one. This definitely will work. The reason that I wanted to wait is that if you follow the same, the usual method, it will work. Yes? But if you don't mind, let me keep it for you to do your calculations in the usual way. But I want to tell you a trick for this kind of calculations. And I want to talk a little bit about the ideas. Let me ask you some questions. You can answer me. If I have a moving particle moving in a space, in a three-dimensional room, how many degrees of freedom the particle has? In other words, if I want to locate the position of a particle in 3 dimensions, how many numbers do you expect me to give you? 3. Yes? I need to give you 3 numbers. So these 3 numbers are called 3 degrees of freedom. So in 3-dimensional space, we have 3 degrees of freedom. Yes, that is the meaning. How can I move? In other words, I can move left and right. I can go, I don't know, to the front, to the back, or I can go up and down. Yes? Yes, so these are the 3 degrees of freedom that I have. Now, let us look here. Forget about the first equations and then focus here. If I ask you how many, so assume that x, y, and z are the coordinates of the point in a space. And then I have one equality. So this gives me one constraint. One constraint kills how many degrees of freedom from the particle? If there are no constraints, the particle has 3 degrees of freedom to move around. But now you are imposing a constraint, one constraint to your particle. You are killing how many degrees of freedom of that particle?
1.
So you are killing 1. How many are left? 2. Okay. So if you ask Geogebra to draw the graph of this function, even though this is above the level of your math knowledge for the time being, but what you expect in general, what you expect to see? Do you expect to see a line? If you ask, yes, that's good. You need to expect to see a surface, not exactly a plane, because plane has to be flat. But it might be a little bit curled or something. Yes? But of course, you are right. It turns out that when the powers of x and y and z are all 1, and there is no, this turns out to be a flat plane. Yes? But at least, I want you to understand, you have 3 degrees of freedom, you have one single constraint, and then what happens? Suddenly, you have 2 degrees of left, so it means that you have to have a 2-dimensional surface. And of course, a 2-dimensional surface might be a 2-dimensional curved surface like that, or a flat one. You need more mathematics to know which one is which, but you need to take my words as granted, this is a plane. Okay? But now forget about this. Now I ask you one more question. If I just give everything that you see here to Geogebra and ask Geogebra to draw the graph of what you see here, what do you expect to get? A plane again? Or what? I'm completing the things that I started with, actually. Assume that I give this equation, exactly 2 equalities, everything that you see I type in Geogebra, and assume that Geogebra know how to draw this. What do you expect to see? Do you expect to see a plane, or what?
I would do that. Yes.
You see that you will get a plane?
Because, or at least which, in a 2-dimensional context, the lines are always straight when we don't have any powers or special functions. When we have a linear function.
No, we don't know, because if you want to show that this is a plane, or if you want to show that this is a straight line, you have to prove it.
Yeah.
That becomes hard. But now my question is that I don't know if Geogebra is capable of doing it, or we have to do it a different way. If you type everything you see here, and assume that you have an application or software which is capable of drawing what you see here, what do you expect to see as the final result, the final outcome? Yes, it should be a 1-dimensional object. Why is that? Can you just elaborate here? Why? Why should I expect to see a 1-dimensional object? A 1-dimensional object, it might be, I don't know, a very strange shape, yes? It might be curled or whatever, but it's a 1-dimensional object, like a snake, or for example, whatever. Yes, why?
Because there are 2 restraints.
Yes, exactly. I told you how many constraints are there? Not 3. 2, only 2. So in 3-dimensional space we have 3 degrees of freedom. how many constraints, how many independent constraints I see. I can write 3 constraints, but 2 of them are independent. 2 independent constraints will take out 2 degrees of freedom. 1 degree of freedom will be left. So my object that I expect should be one-dimensional. Either this one-dimensional object is a straight line or a curved line. But here, it turns out to be, it is a straight line. But this, I want you to understand that. Okay. Now, physically, it is very hard to travel to higher dimensions. But mathematically, it is very easy. Yes? Are you ready? We want to go to 4 dimensions. Wow, I put it equal to t. Now I am in 4 dimensions. Yes? Because I just let me ask you one question. How many variables you see? 4. So it means that I have 4 degrees of freedom. Yes? I have 4 degrees of freedom. And then, how many constraints you see here now? 3. Because I added 1 variable here. Yes? And how many constraints you see here? 1. So in total I have 4. Yes? So how many degrees of freedom I had in general? So I had 4. How many constraints I have? I have 4. So what is left?
A dot.
Is a dot. 0. So it should be unique somehow. So I shouldn't have any degrees of freedom. I have to freeze every degree of freedom. So I am left with 1. So the previous situation was how? I had 3 variables, so I am in 3 dimensions. How many constraints I have?
2.
No, how many constraints I have here and here in total? Again 3. So what is left for me again? A 0-dimensional object. It's a dot. So, but sometimes introducing a new dimension makes solving the problem simpler. I go to the 1 dimension higher, solve my problem in the new universe, and come back again to my own universe, letting that degree of freedom go away. Yes, this t that I brought in, is not in our universe, because our universe is 3-dimensional. When I write it algebraically, by the way, super simple, yes? It's hard to develop some technology to go to higher dimensions, but when I want to go mathematically, I just do it like this. I put a t there. Now I am in 4 dimensions. Now, I solve the problem in 4 dimensions, but I am interested in x and y and z, which belongs to my universe. When I know the whole answer in the 4-dimensional object, I project myself back to the universe and find x and y and z. Okay? I'm not saying that this is always good, but you will see that sometimes introducing a new dimension to the problem makes the problem easier, not harder. Okay? So now let me just try to see how this will work. Can you tell me? You see, I take this one with that one. For me, it is easy to understand. It is 5t plus 2. Do you agree or not?
Yes.
If I compare this one with that one, I can write it like that. Yes or no? If you don't believe, let me just elaborate it here a little bit. So if this is t, I multiply everything by 5. It becomes 5t. And I move this to the other side. Yes? So, okay. Now if you understand what I'm saying, please let me write everything. X is 5t plus 2. And then can you just, in your head, say what is y?
It's 3t plus 1.
No, 3t? Not plus 1. Minus 1, because y plus 1 is 3t, so y is 3t minus 1. And what is z?
2t plus 3.
Plus 3. Do you agree? So what I did, I find the connection of the degrees of freedom in my universe with that single dimension in the fourth dimensional universe. Yes? And then I put it back here in this equation. So what happens? Tell me. It becomes 3 times, let us do it in our head, by the way. You need to trust yourself. 3 times x. I have to multiply this by 3. It becomes 15t plus 6. I multiply this by minus 2. It becomes minus 60 plus 2. And I am multiplying this by 7. It is what? 14t plus 21. Please let me know if I am doing some mistakes. Are you happy? I multiply the first one by 3. I multiply the second one by -2, minus positive. I multiply this one by 7. Yes? And now look what a nice thing is happening. So 15t minus 60 is how much? 90. 90 plus 24t is 23t. So 23 is correct. So 23t. Yes? And then 6, 2 is 8, 29. Move it to the other side. So it becomes 251 minus 29, which is how much? 222. Do you agree? 222. Am I right? So let me double check. 8, 29, 251 minus 30. If I do it, it becomes 221. 222. Am I right? Yes? And then what is t? T is 222 divided by 23. Yes or no? Okay, but I just need this t, because when t is clear, I put it here, I get x. I put it here, I get y. I put it here, I get z. Yes? So what happens, if I put it here, x becomes, let us check. You need to multiply it. Let us check first half-shares for y, if this is correct. So y is 3 times this number, which is 666, and then 23, and minus 1. So what is the answer? 23, and I have to subtract 23 here. Is that your answer? No. Okay, so let us check Rasmus' answer. But at least you did 23, so I hope that I haven't done any mistakes. Did you check my calculation here? Because I want to make sure that you have done it right or not. 6 to 8, 29. 251, 29 is 2, and then I get 3, 2, and then I get 2. Yes, that's right. Okay, let us calculate z. So Rasmus also told us the z number. So 2 times that one is 444 divided by 23. And then what? And then minus plus 3. So 23, and then you get 69. 60 added to this is 513, yes? 444, 69. This is 3, 5, 11, and then 5. So what was your answer, Rasmus?
Almost the same. 521.
21.
Over 23.
Over 23, yes. I remember over 23, but I don't know. Hopefully I haven't done any mistakes. But at least I hope that you agree with me. This method is simpler, isn't it?
A lot simpler.
A lot simpler. So that is the idea from algebra point of view, and from this fantasy that I made for you, going to higher dimensions and coming back. But usually this is the case. In physics it happens a lot. So you add some dimensions to mathematical problem, you go higher dimensions, solve the problem there, come back here. Yes, this is the way that you do it sometimes. Yes, I just wanted to know, but this is really a trick in physics. Okay, so here, and then I don't know, if I go to the other one, let us calculate x finally, and then I can use Geogebra to check our calculations. Hopefully I have done everything right. If I multiply this number by 5, it becomes 1,110. Am I right? 5 times 200 is 1,110. And then divided by 23, and then I have plus 2. And then it means that I need to add 46 to it. If I add 46 to it, I will get that number, agree? Yes. So, yeah, at least you were not totally off track, because you were all get this 23 somewhere. But let us check. By the way, I don't know if Geogebra, because this is 2 equations. The syntax in Geogebra, I have to separate the equations with commas. But I want to test if Geogebra is capable of just typing it exactly like this to see that we get the answer. Okay? So let me just, the lesson is finished, okay? And just I want to see how it goes. Hopefully this is going to work. I think it works. Okay. So I don't know if GeoGebra is capable of typing that. So let me also start recording. Let's record. Okay, so let us see if it works. I don't know. Solve list of equations. I don't think it can solve it like that, but let us test. X minus 2. Oh, you cannot see it, yes? I am just typing it. X minus 2 over, what was it? X minus 2 over 5 equals, oh, that's wrong. X minus 2, I have to put it in a pair of brackets. X minus 2 divided by 5 is equal to y plus 1 equals to y plus 1 divided by 3, I don't know, and then we go here, equals to z minus 3 divided by 4. Let me see. X minus 2 divided by 5, y plus 1 divided by 3, z minus, yeah, that's correct. And let us see if it works in this way. 3x minus 2y plus 7z equals to 251. And then I go to the list of variables. X
z minus 3 divided by 2.
So I understand. So this, I wrote it wrong. Okay, I understand. Thank you very much for correcting me. I will do that. X, y, and z, and then I have to correct it. This is 2, you say?
Yeah.
Yes? Everyone agrees now? Yes or no? Okay, let us see how it goes here. Are these the answers? Yes.
What is that?
So these are the answers. So we got it right. So today is not the lucky day for us. All the numbers are really bad. I have chosen these examples from an Iranian book. Usually in Iranian book they just care about very simple numbers. But this is very bad this time. Anyway. But the way that we did it was right. Okay, and then, so now that we are here, so let me also go to this 3D view. Okay, and then let me get rid of this graphics and cast view.
Bye-bye.
Yes?
We can't see what you're showing. We can only see the recording software, or at least I can see.
Oh, really?
Yeah.
So you missed the amazing part of it. But anyway, you did it correctly. Yes, but let me see if I can find the way. That is good that you brought it. Oh, I don't know, because many things I have to take care of here right now. So I will stop this sharing. I will do another sharing. So here, Geogebra is sharing. Can you see it now?
Yes.
Yes, it's good. At least you see it right now. But I don't know if the recording is in progress now. The recording is also in progress, hopefully. Anyway, okay. So I need to the algebra one. So do you remember? So let me just make it a little bit more beautiful here. So here in three-dimensional space we have 3 degrees of freedom. But if I just draw this one, your prediction comes true. So plus 7y. Of course, this number 25 is very bad numbers. So what has happened here? No. So 3x minus 2y, and then I will have plus 7z equals to 251. So this is out of reach because that number is actually, so let me just see, yes, the plane is coming back. So as you predicted, somehow, by one equation I am killing 1 degree of freedom, 2 degrees of freedom are left, so I will have a rubber sheet or whatever, but this rubber sheet, because of this first powers of x and y and z, turns out to be a flat surface. And let me just see that if GeoGebra is capable of giving you this. So x minus, now I have to prepare brackets, x minus 2 divided by 5. You see, when I put this equality up to here, GeoGebra will draw another plane for you, because that is just 1 degree of freedom, killing one of them, yes? Plus 3 plus 1 divided by 3. So you see here, so far, I am facing another plane. If I can bring it to view, you see? And let me change the color of one of these planes so that we can see better. Okay, so let me just choose that. Okay, so you see, so far, I have 2 planes. But as soon as I add another equation here, equals to, what was that? It was z minus 3 divided by 2, you said, yes? Divided by 2. Let us see how it works. But then, let me see if it works. No, it doesn't work. So GeoGebra is not capable of doing it like that. But
It should be.
no, it should be, yeah, it has given you the equation. Let me see
Well,
what...
I think you accidentally added a 0. Or
Aha, here.
no,
It
it looks
that
kind of strange.
No, but it is given it right. I know that this is an equation of a line, and this should be okay. I don't know. Let me see again how it goes. So okay, but I want to see the line, where the line is.
Maybe.
No, because it is here. It should be. I don't know. But GeoGebra knows, because the equation provided by GeoGebra, I know this is an equation for a straight line. But the straight line is actually out of reach, might be. I don't know where it is actually. Anyway, I can probably work with this. But anyway, these are the very clear ideas I wanted to have in mind. It will help you a lot to understand what you are doing algebraically. The connection between algebra and geometry is actually very crucial. Okay, you can actually probably to discover yourself a little bit more by putting these equations in GeoGebra, see how it goes. But what I'm saying is that if my expectation is that you should see a line, and according to the calculation, GeoGebra knows about the answer is a line, but I don't see where it is.
I think
it needs some out more.
Okay,
maybe not.
No, but because this is red. I don't see any red.
Oh
yeah, no, it should go through the middle.
Yeah.
I have managed to get it to show it, so I don't know why it doesn't want to show it for you.
Aha, okay. So I'm unfortunate today, really. Okay. Anyway, I will stop here. So let me stop recording first.